Welcome to Spark Learning session. Today we will be talking about NLP code along, and this project is about creating a spam filter. If you remember, we talked about this project last time, and we talked about data collections, model selection, data preprocessing. Now, the goal of today is to do feature transformation. Now, before we do feature transformation, let's quickly run our code from our last time so that it's up to date and it runs well. We have to make sure of that. If you don't, then what happens is that we'll try to run this new code, then it can give you a problem. So let's run this code. It's working so well, it's working well right now, and I'll keep running these so that it won't give me a problem later. Now, one thing what we can do here, which I didn't do last time, is that we can look for a we can start working on a tokenizer, a feature transformation. So let's do this. Let's create some tokenizer here. That is tokenizer, and it's going to be input is going to be text, and output will be token text. This is all good. Let's run this and see what we get. All right. Now, next thing what we need to do is we need to write next command. That is we need to remove the stop words from the token text. So we'll create a stop remove token text, and output will be stop tokens. Output column is stop tokens, and we run this. Now next step, what we'll do is we'll do the count vectorizer. We'll take the input column as a stop token, and output column will be cvec or count vectorizer, and it will be assigned to count vec. So let's do that. All right. So let's run the code again, because if it gives this kind of problem, we have to run the code again. And if we do this, let's run it again, it works. All right. So we did that. Now we move again to next step. Can you think about what the next step would be after this step? Think about it for a second, few seconds. The next step will be inverse document frequency, which is called IDF. And what we do is that we'll take the IDF, we'll do the IDF on the CVEC and produce the count frequency inverse document frequency metric, and we will assign that to IDF. So IDF will be equal to CVEC, and output column will be TF underscore IDF. Now we have this. Now I'll ask you to think again what the next step should be. Think about it for the next few seconds. The next step is a string indexer, which is an input column class, and output column will be labeled. There is a ham spam to number indicator. So it will be stored in a ham spam number indicator. What we're doing here is that we are taking class and we are changing the string to index, and they'll be assigned in the output column. That's what we're trying to do here. Now let's create ham spam to num indicator, and it's going to be string indexer. So that's going to be our next step. And as a last step, we have to do some cleanup. And we'll do that using a vector assembler. That is, we'll input columns PDF, IDF, and length, and output column will be features. And this will be the cleaned up version of the text. So let's run everything once again. Now, what we need to do is we're going to create a pipeline of what we discussed earlier into step-by-step process, and that's what we call a pipeline model. Do you know how to create pipeline model? Do you know the syntax? Think about it for a second. The pipeline model should look like this, which is equal to pipeline, and the stages should be ham to spam number, which is a string indexer, and with the tokenizer, stop remover, count vector, IDF, and cleanup. These are the steps we should do. And let's run this. And it says pipeline is not defined. And it says pipeline not defined because it seems we don't have pipeline here in the we don't have the pipeline here in the pipeline is here, and what it's saying is not defined. That's a good question, isn't it? Why the pipeline would not be defined? Because there's a spelling mistake here. That's why it's not defined. All right. Okay. Now it's working. Now, next step. What we need to do is we need to go ahead and with the data in this pipeline model. That is, we take the data and put that to the pipeline model, and you'll get a pipeline fitted model. So you'll give a model which is a fitted pipeline line model, and it's been fitted on the data itself. Pipeline model, and there's a fit on data. So we apply this data on pipeline, and it is giving error. Now let's do this. Let's make sure that we are in correct step here. So this is wrong here. So it should be pipeline model, not people model. And that is a mistake. That's what a mistake we made. I cannot recognize the pipe class ABC meta. What does that mean? There is something wrong with our stages here, because it shouldn't be like that. So let's check what's wrong here. Now let's run this again and see if it's working. And we have made mistake in tokenizer, and we'll fix that again, and let's run this again. Now it's working now. All right, that's a good thing. All right, that's a good thing. So it's working now. For next step, what we need to do is we will transform the data using a fitted model. Now we'll transfer data, the same data, and we'll get a clean data out of that. So let's do that. Let's get a clean data and use a pipeline model which is fitted on data, and we'll get a data, process that the same data, and get a clean data itself. All right. So we did that, and Now, next step, we'll select few columns from the clean data and we'll redefine a clean data. Clean data is equal to clean data labeling features, and finally we'll show the columns. And these are columns we have. It's beautiful, isn't it? So let's quickly summarize what we learned today. We talked about enabling code along, and this was about spam filter. We continued from last session into feature transformation. And the feature transformation, we had a certain steps. First of all, we need to do some string. We took the class and turn that into a label, and we use different stages such as tokenizer, stop over, stop remove, count break, IDF, and cleanup. And these were put strang. We put into a sequence of stages and create an ETL pipeline model. We feature that on the data, and we use that same model to clean the data and bring out the features we want, such as label and features, and we showed that. So that's all for today. Thank you so much. Have a nice day.